Hi, in this next video, we're going to show you how to differentiate from first principles. That is where you have the following function when the limit of h tends to 0, and you have the function of x plus h minus the function of x divided by h. So what you want to do, you always want to break this up into 4 different parts. So your first part will be function of x plus h. Your second part will subtract your original function. Your third part will be divide by h. And lastly, your fourth part will be any remaining h will tend to 0 or become 0. So in my equation, y equals x squared, if I just use a basic example. So firstly, I'm going to say the function of x plus h. That means I must change my x value into x plus h, and in this case there's a square there. That means you're going to square these bracket x plus h and x plus h. So if you cross multiply that, you will get x squared plus 2xh plus h squared, and that will be step 1 complete. So step number 2 say, take the function of x plus h and subtract your original function. So this is y equals, it can also say the function of x equal, which means y. So this is my original function. So I take this function x squared plus 2xh plus h squared, and I'll subtract my original function, which is x squared, and this always will cancel out your first and your last term. So that means now I will just have 2xh plus h squared remaining. So now step 2 is complete. Step number 3 say divide all terms by h. So step number 3 say take the function of x plus h minus my original function and then divide by h. So I have 2xh plus h squared, and I have to divide this term by h and this term by h, and then this h will cancel, and this h will cancel with one of those h's. So my remaining term is going to look like this. So the last step is step number 4, the limit of any remaining h will turn to 0 of the function of x plus h minus the function of x over h. So that means any remaining h will now become 0, and my final answer for the derivative is x equals 2x, or y equals 2x. So in our second example, we are now going to use first principles where we have to include the binomial theorem. This is when I have a bracket with a very big or fraction exponent. So this 2 root x is the same as 2x to the exponent of a half. So if I follow my 4 steps, step 1 say the function of x plus h. So step 1 say, I must take the function of x plus h. So I'm going to change this x by 2, and I'm going to write x plus h to the exponent of a half. Now to factorize this, I'm going to use the binomial theorem. So that means if there's a number in front like a 2, you will just write it outside the bracket, and then I start applying the exponent to the first term. So I'll have x to the exponent of a half, apply the exponent to the first term, and the second term, the h, I will start with the value 0. Then I'm going to continue. I'm going to differentiate. This is a power function, multiply to the front, minus 1 from it. I'm going to differentiate the first term. I have a half, x, a half minus 1 is minus a half, and my h to the first, divide my a 1 with a little 1 exclamation there, and this basically means 1 times 1. Then I'm going to continue, plus, I'm going to take my minus a half, multiply to the front, minus 1 from it, but I already have a half, I take the minus a half, multiply to the front, x minus a half minus 1 will give me minus 3 over 2 now. My h goes to the second exponent there, and I'll put this over my second exclamation. So now I can continue, plus I have a half there, I have minus a half in a bracket. If I take this exponent, multiply it to the front, minus 3 over 2, and then x minus 3 over 2 minus another one is minus 5 over 2, and my h goes to the next exponent, divide by my third exclamation, and so I can continue with this, and this will be my binomial theorem. So now I can simplify this by writing it out in the following sense. So I have my 2 outside, I have x to the power of a half there, plus if I do this on my calculator or just write it down, I have got a half, x to the minus a half, and a h there, and so I can continue. If I have this, I will get 1 over 8, x to the power of minus 3 over 2 h squared, and so I can continue with all of this. That's going to make my values addition. So normally you can just do 3 or 4 terms if you wanted to do the 4th term. And if there's a number, you're going to multiply this number into all the terms. So you will have 2x to the power of a half plus 2 times that half will cancel out. You will just have x a half h plus 1 over 4 x to the minus 3 over 2 h squared. And so you can have all the values. So that is the first line complete by using the binomial theorem method. So step number 2 say the function of x plus h minus my original function. So now I'm going to take my function 2x to the power of a half plus x minus a half h plus a quarter x minus 3 over 2h squared, and I'm going to subtract my original function, which is 2x to the power of a half. And this will always cancel out your first term, so the remaining terms will be x to the minus a half x plus a quarter x minus 3 over 2h squared. And if you had any other terms, it would follow down. The next step will be take the function of x plus h minus my original function and then divide by h. So I'll take each of these terms and I'll divide by h and I'll divide by h. So if I divide by h, the h will disappear there, and this one I will have 3 over 2. If I divide by h, I will still have 1 remaining h. And then my final answer will be the limit of any remaining h will now become 0 of the function of x plus h minus the original function, divide by h. So any remaining h will become 0. So if this is 0 times anything, this term will fall away, and only x to the minus a half will be my answer there. So in my next example, my value that I have to differentiate from first principles is now a fraction. I've got a function of x and divide by a function of x. So when I have a function of x over a function of x, I still follow the same 4-step procedure. So the first step is the function of x plus h. So I will replace all the x values only by x plus h. So 5x plus h plus 4 over 2 minus 3x plus h. So if I cross multiply or multiply this bracket out, I'll have 5x plus 5h plus 4 over 2 minus 3x. and the minus times the plus is a minus 3h. So there is my x plus h integrated into the top as well as the bottom. So step number 1 complete. Step number 2, say take the function of x plus h and subtract my original function. So I take my function of x plus h, 5x plus 5h plus 4, and I divide it by 2 minus 3x minus 3h, and I subtract my original function, which is 5x plus 4 over 2 minus 3x. So now, basically, I have a fraction minus a fraction. And when I have a fraction minus or plus a fraction, I always need to find an LCM. So if I find my LCM, I can just use my two bottom terms like that. So I'm going to write down my two bottom terms, 2 minus 3x minus 3h, as well as 2 minus 3x, like this. And I'm going to say, this term going to this bottom LCM, this cancel out, so this will be the remainder that I have to multiply at the top, 2 minus 3x. And I have already there 5x plus 5h plus 4 minus. So I've taken this, divided into there, the remainder I write down plus what I have already. Or you can first write down what you have already, 5x plus 4. I say 2 minus 3x going to there. This one will be the remainder, so I write it there, 2 minus 3x minus 3h. And all I need to do is to cross multiply. So this is going to be 2 times this term, 2 times that term, 2 times that term, minus 3 times that term, minus 3, as well as that. So you will know that you have quite a long cross multiplication that will give you the following. 10x plus 10h plus 8 minus 15x squared minus 15xh minus 12x minus 10x plus 15x squared plus 15xh minus 8 plus 12x plus 12h, all divided by my LCM of 2 minus 3x minus 3h and 2 minus 3x, these in brackets. So now you will see that almost all your terms cancel out. I've got a 10x and I've got a minus 10x. Only the terms with h's do not cancel out. If you still have a term with h, then you've done something wrong in your cross multiplication. So I've got plus 10h, and if I go across there, I've got plus another 12h. It will give me plus 22h over my LCM 2 minus 3x minus 3h, as well as 2 minus 3x. So once again, all these terms, 10x minus 10x, the plus 8 and the minus 8, so all your terms will cancel out. 15x squared plus a minus 15x squared, minus 15xh plus 15xh, minus 12 plus 12. So the only remainders that you will have is these ones that I'm going to circle in red and circle in red that you can add together. So that will be your top 22h at the bottom. So now we've done step 2. Step number 3, say, take the function of x plus h minus the function of x, divide by h. So all I need to do is now multiply by 1 over h, and now my h value cancel out. So my final answer then for the next step will be step number 4, where I have to put the limit of h tends to 0 of the function of x plus h minus the function of x over h is 22 over 2 minus 3x minus 3, that h becomes a 0, 2 minus 3x. So basically I will have 22 over 2 minus 3x and 2 minus 3x, or I can rewrite it down as 22 over 2 minus 3x square like that. And that would be the differentiated value of this fraction by using first principles. In our next differentiation from first principles, we are going to differentiate sine of x by using first principles. When I do sine or cos, there's two limit calculations that I need to remember. So if the limit of h tends to 0 and I have the sine of h over h, the limit of h, this value will give me 0, because if I replace the h by 0, I'll get 1. And if I put the 0 in, I will get 0 there, divide by 0. So these are the two things that you need to remember. So if I go there, I'll follow the same 4-step procedure. So step number 1, say the function of x plus h. So I'll write it down as the sine of x plus h. Now on your identity list, you will see what sine a plus b or sine x plus h is. So you will use your identity to see that this say you must now write sine x, the cos of h, plus sine h, the cos of x. That you will find in your squared identity or compound identities. So now that's step number 1 complete. Step number 2, say the function of x plus h minus my original x. So I have my sine x cos h plus sine h cos x. Subtract my original function, which is the sine of x. Now you'll see that you've got 1, 2, 3 terms. Now you will always want to combine term 1 and term 3 together. So you're going to rewrite sine of x, the cos of h, minus the sine of x, plus sine h cos x. So then from these two terms, I'm going to take sine out as a common factor. So I'll take sine out as a common factor, and that leaves me with cos h minus 1 plus sine h cos x. So that is step number 2 completed. Now I'll go to my next step. Step number 3, say I take the function of x plus h, I minus my original function, and I divide by h. Now when I get to this sine x cos h minus 1 over h plus sine h times cos x over h. Now I get to this scenario where I have these two things in place. So in my 4th step now, when I add the limit of h tends to 0 of the function of x plus h minus the function of x divided by h. Now I have the limit applied to this. Then I'll have the sine of x. So the cos of h minus 1 over 0, if I apply, that will give me a value of 0 plus the sine of h over h, when I apply the h to 0, will give me 1 times the cos of x. So 0 times sine will just be 0. So my function will just be then the cos of x. So if I differentiate sine x, I will get cos x by using first principle differentiations. Now the reverse, if I want to differentiate cos to minus sine, you will use the same procedure, and that will give you the answer as well. Differentiate from first principles.